My name's Chris McCain. I'm part of the Application Networking and Security Division at Broadcom.
I'm Alex Fanous. I'm a staff architect in the VCF Advanced Services team. So we're the team that works on bringing new products and features to market. I've been working heavily with the VMware Private AI Foundation with NVIDIA solution. So we thought this was a great partnership. Looking forward to talking to you guys today.
Yeah, so this started 3 months, 4 months ago or so. I think it was more an interest of Alex and I, just out of curiosity, seeing how these two products can play together. And the more we started working on it, then my leadership got to his leadership, and they thought they had this great idea about it. And Alex and I were like, what do you mean? We've already been working on this. And they were like, great, do it at Explore. So here we are at Explore. So we're going to break this up into two parts. Alex is going to take this first part here, and he's going to run through some private AI discussions, and then we will pivot into how and why we want to protect the private AI. So Alex, take it away.
Thank you. So first thing I just want to do is I just want to level set. As we start talking to people, new people get brought into this conversation. So we want to make sure we're all speaking the same language. So there's a couple of terminologies I want to work through as we kind of process this. First one is a large language model. This is going to be referred to as a completion model. It is what's answering the questions for you. If you use ChatGPT or any kind of chatbot, it's going back to an LLM and then processing the information, giving you the answer. RAG is a way that we adopt this to work with your data. Instead of fine-tuning or training your own model, you take your data and pair it with that LLM to get you the best bang for the buck. These are very simple to get started on. They can grow to be pretty complex, but it's an easy way to interact. So a vector database, this is a special type of database that allows you to do similarity searches. So you can ask something like, you're talking about Apple, are you talking about the food Apple, or are you talking about a tech company that competes with Samsung? PG vector, this is an add-on that goes into Postgres to make it a PG vector database. Sorry, make it a vector database. We deploy Postgres and do the PG vector plugin through DSM, Data Services Manager. So that's one of the capabilities there. But with a lot of these systems, you can bring your own database, you can swap it out to something else. In this solution, we have two ways of deploying things that consume GPUs. The first one is a deep learning VM. This is a VMware opinionated VM that gives you the capabilities that have AI tools built in, Conda, PyTorch, Jupyter Notebooks. One of the big things here is we detect the GPU you give it, install the correct driver for you so you don't have to worry about making that pairing, and then consume. We can also deploy this through Kubernetes and a GPU operator. The nice part here is these are objects in vCenter that you can consume. So they shouldn't be too scary to everybody that's here. There's objects that you're coming back to in vCenter, so that'll help us in this conversation to build off of. Training. Training is the process of actually taking data and building a model. Training comes in two factors, training, but it also can be fine-tuning where you're taking a base model and then up-leveling it with a little bit more information. The way I say this is the technical term is we're just smushing that data into the model so that model now knows more. This is a different way of doing it versus the RAG. Inferencing is now you have a model, you have the information, we're pulling information out so we can consume this. So this is your runtime. This is where we see most of our customers really leveraging the platform and building on top of. So a large language model. This is how we're interacting with it. We're asking a bunch of questions. A lot of people think of this as just text, and in some ways you're right? When we're interacting with this, a lot of the stuff, we take images or voice, we translate it to text, and then we feed it in. But it could be a lot of different things. One of the things that we're seeing now that's also growing is this idea of LLMs talking to LLMs. You ask one question, and that may launch 5 or 6 other questions that are going to different LLMs and different processing different information. Sometimes what you're seeing customers do now too, is they'll ask one LLM a question, it then asks another LLM to verify the first one was correct. Sometimes that's in order to be more cost effective, maybe it's to get a better answer or speed up or improve accuracy. Now, training from scratch has a couple of kind of issues. It generally takes a lot of time. Llama 3.1 was something like 48,000 GPUs, 90 days. And if we're doing it in AWS in US dollars, it would be something like $630 million. It's time intensive, but also money intensive. It takes up a lot of resources, and it's not perfect. So what we're looking at doing is ways to improve that. First way is prompt engineering. That's asking a question in a very fulfilled way of elaborately telling it everything you want it to do. One is fine tuning, like I said, getting more information into the model to process that. And then RAG. So let's go into a next slide here. In a couple slides, I'm going to tell you more about RAG. But why are we doing this, and why are we trying to improve LLMs? Well, they're not always perfect. What we call that is hallucinating, right? They want to give you an answer. Silly things like just telling an LLM in the prompt that you're a good LLM and you're going to give me a good answer will actually improve the response. It's like working with an intern. They're only trained up to a certain point in time, so that you lose it right there. And one of the big things is you have no idea where this answer came from. So what we're looking at doing with RAG is kind of changing this so we know we're giving it known good information. We can update it as often as you want. If you're using private AI services in V9, you could say update it every day or manually go in there and trigger something, but we know it's getting updated on a frequent basis, and it's going to tell you where it got that data from. Here's a PDF I got it from. Here's the Confluence page I got it from. So you know you can go back and check it. So let's talk about what a RAG workflow looks like. I'm going to break this down into kind of two views. A logical view is, first thing is we're going to take the data, we're going to inject it, we're going to embed it into a vector database. Now we can search that database. User's going to ask a prompt. It's going to search the database for anything that's relevant. It's going to take that information. It's going to come back to that front end, and we're going to say what we call an enriched prompt. It's going to go back out there and then go to the LLM. Now this is your question as well as all the data that came from the database. That's then going to go back to the user. So now let's take a look at what the solution is. I'll only spend a minute or two here, but when we're talking through here, we work, this solution is now built into version 9, if you heard my secret comment earlier. Everybody gets it for free. We work with OEM manufacturers to make sure we have the right servers. We can give you recommendations on what's working. There's some capabilities in VCF that we can build on. Being able to vMotion a GPU-enabled workload, so that way you can patch a cluster without having to take workloads down. But when we start building on top of that, we have a bunch of AI services we do that. Part of it is our automation framework, making sure we have quotas, we have policies, role-based access control. We can have different ways of controlling access to this solution. The bottom layer, bottom 4 boxes in this blue box here, the middle blue box, those are really new things coming out in 9.0. A model runtime, being able to go through a no-code, low-code UI, choose a model, choose the resources, get it deployed, and then from there, we're going to point it at our data, tell it how often we want to index this. It can be dynamic, and then we're going to pair those all up together in what we call an agent builder. Now, we pair with NVIDIA, partner with them, where they run NIMs, NVIDIA Inference Microservices. It's a great way of getting a lot of capabilities that they have and being able to spin these up really quickly. What I mean by that is we can run specific models, but we can also do things like text to voice, voice to text. We're working with one customer right now that's doing a digital human that's then being able to see like it's somebody like in a Zoom session talking to you while you interact with the RAG. These are things that you can do with NIMs and spin them up on our platform in a consistent way. So when we come back to our story and what we're looking at here, I want to start taking that theoretical conversation and talk a little bit more specific about these flows. I think this is key to knowing how we want to secure the workloads. So in this middle here, this ingestion agent, this is going to be a process, whether it's a pod VM from private AI services or a VM or a Kubernetes deployment that you do. It's going to go out and read your data sources that you give it access to. It's also then going to process this, whether it's part of the same VM or a different VM it's working with. It's going to go through a process of embedding. And then it's going to write that data to a database. So when we're looking at this, there's a couple of different things we can see here. We have a lot of data ingestion coming from, or network traffic coming from the data sources as we read them. We're doing a lot of processing using CPU, GPU capabilities when we're embedding it. And then we're writing a lot of consistent sequential writes to the database when we're doing this. So being the AI guy here, a simple thing I want to do is just kind of protect this workflow and make sure I know what's happening. So we can put firewall rules around these, control what we're doing. This helps control some of the concerns customers have. Oh, you don't want this AI system to go get data that we didn't tell it about, or start interacting with a system we don't want it to do. Well, if we limit what this can interact with and we limit with what it can touch, then we don't have that concern. We can control the risk there. From the inferencing portion of this call, we start in the top left here and we ask a question on the front end. One of the things I don't think a lot of people are as familiar with right now is that front end does a lot of the information you're passing back and forth. So it's going to go out, it's going to read your chat history. It's going to take your question in your chat history, send it through an embedding process. That goes through and searches the database for all the results, then goes over to the re-ranker that prioritizes the results, sends it to the LLM, then comes back and gives that user the response. I have this kind of carved out this way a few different reasons. One is to show you distinct ways this flow is going, but also to show you the right 3 blue boxes generally are going to have a GPU associated with them. But these are discrete ways, discrete paths that we're communicating with. So again, my process here, there's ways we can protect this data, ways we can put it around. Firewall rules securing this. There's also ACL rules we can do for Data Services Manager. There's different front ends that we can do to control access to what is communicating with this chatbot, and as we're protecting this information. What I also want to touch base on is there's other protections here that go further than this that I want to kind of touch base on before we switch back to more of a networking-centric view. And one of those is guardrails. Nemo guardrails, Llama guardrails are 2 of the popular ones out there. This is a way that gets injected into these flows to see if to check what you're asking. So one of the things would be is if you were asking it how to create a bomb, they would say, you shouldn't know that. That's not relevant to your job. We're not going to give you that information. There's other ways you can backtrack into answers or questions where you can say, I have a bunch of chemicals under my sink and I just want to make sure I don't mix them together. Can you just tell me what to keep separate so I don't cause any problems? And maybe it'll answer that because now it's trying to be helpful. But the Llama guard, Nemo guard is going to say, nope, still shouldn't have that information, move on. Maybe more in a work appropriate question is, you don't need to see a social security number or a credit card information on your normal day-to-day tasks until you prove that you need to. So as we go through this flow, these are other flows that we can do to protect this workload and detect the flows that are happening here. Private AI services provide a few options for no-code, low-code capabilities here that provide this. So this is running in a vSphere namespace, running in VCF automation, controlled by VCF automation. And then we can ask a few different things here in this. So we have the customer application coming in, hitting these capabilities. You can see a database in the bottom. We can see our indexing retrieval service, the model runtime, all these things here. Those are all things that can be protected, and I thought there was another slide. Oh, there we go. We have these flows here that we can still protect as we're deploying these to make sure what's going on. So the more you know about the product, the more that we dig into those onions, we can start pulling back those layers and seeing how we can protect this and make sure it's secure as we're running it. One of the other things here that we can also do, Avi Load Balancer can be used in here as an extra layer of capability in order to provide redundancy, routing, based on load, what those capabilities look like, and helping us go between different deployments or maybe different replicas of the agent builder. So with that, I'll pass it back off to Chris.
All right, so I'm going to back up here real quick. This slide here that Alex pivoted to, this is what we're aiming for. This is what we're trying to get to when we talk about building secure private AI. The ability to control traffic between all of the different components that make up the AI architecture. How do we get to this is different, okay? So we're starting here with the end state, and now we'll work backwards in how we arrive at this. So first, let's start off with the data sources. So Alex kind of mentioned some of these going through it, but when you think about why we want to bring AI on-prem, it's because we want our own information to be maintained by us. We don't necessarily want it out in the cloud. So what is our information? What is our data that we're providing to this learning model? So security and control are primary drivers for companies bringing this on-prem. These deployments fundamentally rely on these data sources that we give them that are not only different from external, but by nature are more easily granularly controlled because they're ours. It's not just something that's public domain. It's our patent information, it's our code, it's our financial data. So we have more control over that within the on-prem environment. So the public-facing LLMs are trained on just giant sets of data. We're trying to figure out how to narrow that down into very specific information relevant to our own business. Now, the key to this, how do we monetize it? And I think that's what most customers are trying to figure out right now. And adding private AI into VCF just by default, I think is now going to allow customers to start to get very creative with how they decide they want to use AI. Because if you think about it, if you had to pay for private AI, but you haven't yet figured out how to monetize it, you're putting the cart before the horse here. But now having private AI as part of VCF, you're gonna have the opportunity to say, well, let's try this, let's try that. It's gonna give you an opportunity to test and fail faster and keep iterating until you find a way to monetize your private AI. The internal data is rich, unique, and highly valuable assets that allow the AI to be tailored for specific business contexts while maintaining strict security and privacy. So what are these data sources? What is it that we're going to be giving? Well, there's structured data. So data that is highly organized, easily searchable, typically in databases or our business systems, CRM, whatever customer information we might have, we're feeding that to the LLM. CRMs, ERPs, our own internal databases with product information, transactional records, data warehouses, custom-built databases, all these things that hold relevant information. So the spectrum of controlled internal data sources are unstructured data. This is information not organized in a predefined manner, represents a massive source of valuable information for the LLM. Or internal documents, financial reports, legal contracts, playbooks, technical docs, engineering specs, right? We've done internally, we've done a lot with AI with our own code development, with our own technical documentation. In application networking and security, we're building AI chatbots that will help you build firewall policy, that will actually know and understand our documentation so that you could use a chatbot that says, hey, I see these two virtual machines communicating and they're not supposed to be, suggest a rule for me. And it'll understand the context of the documentation. It'll know how to build security groups and security policies and construct firewall rules on your behalf. Or in the network detection and response, we're using an AI chatbot so that if you're not familiar with how a cyber attack works, you can actually use natural language to say, hey, show me all systems impacted by this particular campaign. And it goes through and finds it. That's all built on our proprietary information. That's not stuff that we want to put out in the cloud. Communication platforms, so maybe wikis or knowledge bases, intranet portals, SharePoint, Slack, Google Chat, file servers, email archives. These are all those private sources of data. All right, so what is it that we want to secure? How do we want to secure it? Well, think about this. In the next N number of years, as more and more organizations start to build private AI, it's going to become a high-value target to malicious threat actors. There's no question about that. If you think about it, if you don't have private AI, you still have those things, right? Your crown jewel applications, your moneymaker applications, you got Active Directory, you got DNS, hell, your hypervisor is a high-value target to threat actors. But when you add AI into the mix now, think about what you're exposing to an attacker. If you're bringing financial information into a learning model so that you can use natural language to try and identify quarterly, annual reports, whatever it might be, and you give attackers access to that, they can cause some serious damage. You need to be able to protect those things. So we cannot overlook the necessity for security when we do this. Now, here's the reality of this. The things that I'm about to show you here, that using vDefend to protect it, this is no different than protecting any other VM or any other container in your organization. But again, when you think about AI, this is a super specialized use case that you need to implement security for. Because failing to do this, you're basically giving an attacker a natural language capability to identify information about your company. So what do we need to protect? First off, we need to protect data ingestion. The sources of truth for training the learning model. What is the learning model allowed to use as information in order to give back information to those who are using it? So that's one thing. Two is the intra-AI component communication. Where do these learning models come from? If I'm a data scientist, where am I getting a learning model from? The internet. Well, we all trust everything we download from the internet, right? So we're getting these learning models from the internet. Now, with Private AI Foundation, we can put guardrails as to what models become available, but ultimately the model still came from the internet. So you might have your choice of 3, 5, 10 different models, whatever it is, but you didn't make that model, somebody else did. There could be vulnerabilities in there. So we have to be able to understand that model well enough to be able to control the way things communicate between them, because if a vulnerability is exposed in that model and we are using it, then we are then susceptible to that vulnerability. And then the final piece is the user consumption. So who's allowed to access this information via the chatbot or the app or whatever it is that we have? All right, so how do we do this? Well, first off, controlling data ingestion. Think about how bad this gets if we don't properly control data ingestion. Think about how bad it gets if we don't control the source of truth for training the learning model. If an attacker gets in, right, they're in the network for a little while, they realize, oh, there's a learning model, there's private AI. What happens if the attacker starts loading documents into that learning model? Right? Documents that are not accurate based on what we would want. They're basically poisoning the entire learning model. So now the results that we get back from that learning model are contaminated by data that we never intended to put into that learning model. So the data sets that are used to fine-tune the model that contain sensitive information, if that is combined with information that's completely irrelevant to what we want, then the whole AI model is useless at that point. So unsecured communication allows the attacker to eavesdrop and steal data. Unprotected access allows them to poison the output. So controlling this, if the threat actors do have access, then the validity of the learning model output is compromised. We have to ensure we know what's going into there. So you can see there from the image, right? The good stuff that's going in, the bad stuff that's going in, and then the output is a combination of the two. And meanwhile, this poor user who's using the chatbot is none the wiser, and what are they thinking? They're thinking, oh, okay, I'm getting good information. All the while, it's actually not 100% accurate. All right, so here's what that looks like. How many of you are familiar with VMware vDefend? Some of you. Okay, so for those of you who are not, here's a crash course. Take the idea of a physical firewall, your checkpoint, your Palo, your Cisco, whatever's sitting there. Abstract that into the hypervisor and put it at the virtual NIC of every workload. That's VMware vDefend Distributed Firewall. It's a firewall sitting at the vNIC of every single workload running in the hypervisor. So if you think about the hypervisor today without vDefend, you know we're already passing your traffic, right? It's going through a distributed switch, then it goes to the physical NIC, trunk down, right? Your VLANs are trunked down to the physical switch. So we're passing your traffic. So years ago, VMware got the idea, says, wait a minute, we're already passing the traffic. Why don't we inspect the traffic? Why don't we look at it? Why don't we see where it's going, where it's coming from, and determine whether or not that should actually happen? That's what VMware vDefend does. So if you are a virtualization engineer right now, this is probably the single most powerful tool you have to protect your VMware environment with vDefend. So what we're showing here is using VMware vDefend security policies to control the data sources into the LLM. So let me walk you through it. You see the rule there, it's called PAFE, and then we have a rule name, DSLLM. So the source is PAFE DS. That's a security group. That security group is made up of any virtual machine or container object that is tagged as PAFE DS. Okay? Then the destination is PAFE LLM. Now, look, I'm the vSphere guy handling this. Alex is the AI guy. I don't know all the nuances of his model and his architecture. So I went to Alex and I just said, hey, look, tell me all the objects, just high level. I'm not gonna get into the weeds yet. Just give me a high level. What are all the objects in your LLM? And let's tag those as PAFE LLM. And then we build a security group made up of anything tagged with PAFE LLM. Then we build a policy. If the source is anything tagged PAFE DS and the destination is anything PAFE LLM, we're gonna allow it. What did we just do? We just restricted access into the LLM to only the things that are designated as PAFE DS, a data source. It's gotta be a legit data source in order to get in. I don't know the specifics yet, haven't got into that. But what I want to do is I want to make sure that my private AI has at least a foundational security, that it's secure by default before I start getting into deeper and deeper levels. This probably takes 10 minutes to do. Not doing this would be extremely negligent because I'm not talking about an overhaul of the operational model to protect private AI. I'm talking about a few minutes of Alex and I working together. Working with the data scientists to know, here are the things they're using, here are the sources, let me build a rule. Let me figure out how to not let the LLM data get tainted because we have a malicious threat actor that's trying to load other data. And then you can see beneath it, there's another rule that says any to PAFE LLM, drop it. Anybody know why I added the drop rule? Could be just in case, but anybody know what the default rule is for VMware vDefend? It's allow, okay? And that's by design, by the way, because imagine in a brownfield environment, if you deployed vDefend and the default rule was a drop, the support calls to Broadcom would be through the roof. Hey, I deployed vDefend and my entire environment stopped. Oh yeah, we forgot to tell you. No, it's allow by default. So in a brownfield environment, when you're deploying this, not only do I want to create the rules that allow the things I want, I have to build the rules to stop the things that I don't want until I get to a point where I can flip that default rule, and then it's just a matter of whitelisting those things. But I think we can all agree that's one rule. That's pretty simple to be able to control. Now, I could take this a step further, and I could build, actually, let me not go to that one yet. Alex talked about having, SharePoint or a wiki or a web page. So I could actually use vDefend to create FQDN rules that say, hey, if the source is the PAFE LLM, and if I want to get really specific, I could go to Alex and say, hey, Alex, which specific component in your learning model is the one that's retrieving the data from the wiki, the SharePoint, the Confluence page? And I could build an FQDN policy that's way more specific than this, that says if the source is that one component and the destination is any of these 4 URLs, then I'll allow it. So I can be general or I can be very specific. This is not an all or nothing proposition, and you can pick and choose how granular you want to be with the way these things go. All right, controlling the private AI data ingestion. So here we have our data sources. You can see here I've got L7 DNS for URLs, and now this is exactly what I'm doing. If you look at the second rule there, allow access to training. You can't see the words, but it says training. I've got a source of PAFE LLM. Destination is any. And then in my context profiles, what I've defined are all of the legit URLs that we can go to. So this is me being more granular. Look, this is still not a lot of work to do. In fact, building the policy takes less time than saying, hey, Alex, what are all the URLs you need? You know why? Because Alex is a busy dude. So it took him 4 hours to respond to me. It took me 5 minutes to build a rule. Building the policy, the manageability of vDefend is simple. It's really understanding the environment, having the right information to be able to build the right policy that takes more time. But now here we're limiting it to only specific URLs. And then, of course, at the bottom, I've got my block rule again because my default policy is set to any allow. All right, securing access to the learning model output. So who should have access to the chatbot or to the web app that has this information? And there's a couple different ways that we can do this. Now, obviously, there's authentication, but let's not confuse authentication and authorization with network security. I'm focused here on the network security aspects of gaining access to the model output. So let's say that I have this learning model that's all about financial information. It should not be available to anyone in my organization. It should be available to the finance team. And by the way, my finance team comes in through a VDI environment. So now I can say, hey, look, if you're in one of these VDI environments and you're going to the chatbot or the web app, I'm going to allow you. Or I could even use identity firewall. I can say, if you're part of this Active Directory group, then I give you access to this chatbot. But we're controlling at the network level who has access to the application that provides the information. So here's a couple of examples. I've got the data scientist desktop group, and I got the data scientist AD group. So this is Alex and his buddies, the data scientists. They have their own set of desktops that they work on, and they are also part of a data scientist Active Directory global group. So I built some policies here. The first one says allow data scientist desktop. So if the source is a data scientist desktop and the destination is LLM01, then go ahead and allow the traffic. Then the second one says if the source is data scientists, so this is different. This is not data scientist desktop. This is the actual Active Directory. I want you guys to think about this for a minute. This is really cool that I can actually build a firewall policy based on the SID of the user ID belonging to a specific AD group. Because we're looking at the logs. We're looking at Active Directory to see how you logged in. Oh, it's Chris. Chris is not part of the data scientist group. Well, then Chris is not going to be able to gain access. Alex is part of the Active Directory group, so he's going to be able to have access to this. It's a really good way to be able to fine-tune the access to applications based on who you are. Again, this is not authentication. I'm not authenticating Alex. I'm not authenticating Chris. I'm looking at the SID of the user to determine whether or not they gain access. It's pretty neat. Okay, now, the other piece, securing intra AI. So we talked about these models being downloaded from the internet. Now, of course, these models should already have some level of security from the standpoint of how they're communicating and how they've been designed as an application architecture, so things like TLS. But segmentation of the AI platform is critical to making sure that vulnerabilities in any one component do not expose the entire model to a malicious threat actor. So we need to have strict access controls and authentication across every component. So here's what happens though. I'm the vSphere guy again. I don't know this model. So I go to Alex. I say, Alex, how does this model communicate? And Alex goes, I just downloaded it, man. I just use it. It works for me. So we have to figure out now, how does this thing actually communicate? How are we supposed to control traffic between something that neither of us really understand the intricacies of how these components communicate? So in this diagram that we saw earlier, right, this is our model. So Alex and I get together, we're like, oh, hey, look at that. That one does that, and that one does that. Well, what port is it? What protocol is it? And we look at each other and we go, I don't know. Right? So we have to figure this out. And if there's no documentation or anything, then we'd still need to be able to do something. So here's what we can do. There's two ways we can do this. One is analysis and automatic rule recommendations with a tool called security intelligence. How many of you heard of security intelligence? Okay, so we have a tool that's part of the vDefend firewall product called security intelligence. So you guys saw that group that I built, right, for PAFE LLM. It's already tagged. So now I can go and I can take security intelligence and I can point it at PAFE LLM and have it watch everything with this tag. And after 30 days, I come back and it shows me every flow that's happened across everything tagged with PAFE LLM. Not only does it show me every flow, it also gives me rule recommendations of what should be created in order to control the traffic based on all the flows I just saw. Not only does it give me the rule recommendations, it gives me a button I can push to convert those into actionable, enforceable policy. So we've taken all the guesswork out of the planning and implementation of firewall policies for this specific application. So now, what's the catch? The catch is a human has to push the button. That's the catch. So what I gotta do now is we got all these flows, so I gotta bring Alex in, I gotta say, Alex, here's what this saw. And we gotta look at it and say, does that look right? Does that look right? And yeah, that one looks good. Okay, that's supposed to talk to that. Well, we go to this and say, okay, well, that's the embedding and that's the LM. So yeah, that's supposed to talk to that and that's good and that. So we're looking at what was found to determine, is this accurate? And if it's accurate, it's time to push the button. If it's me, I'm gonna make Alex push the button because then he's accountable for it, right? But really, that's the hardest part, is finding somebody who's willing to be accountable for the creation of firewall policy for an application that could in fact be very business critical. Now, realistically, we just said the default policy is any allow, so you're not gonna break the app. The worst thing that happens in this scenario is that you missed a policy, right? You missed a recommendation or a rule, and so it hits the default policy. But that's why you log the default policy, so that you can get notified of something hitting it, then you can go back and build the policy. Now, the absolute worst thing that could happen is if there's already a malicious threat actor that's taking advantage of a vulnerability, and I just scanned it, found it, and built a policy to continue to allow it. That's what scares me about it. That's the tough part. Now, there's another option, is to upload a manifest that defines the appropriate communication. So having this security intelligence tool, now maybe I go to Alex, because Alex has a new model. I say, Alex, do you know anything about the new model? He goes, absolutely. Actually, I have a file, a CSV file I can give you that has all of the communication for it. I upload the file, it generates recommendations, and we can convert that into policy. So there's different ways that we can do this in order to protect the environment. So that's SSP. SSP is our security services platform to monitor the flows, gives you a visual mapping. So I can sit down with Alex and we can see an entire map of every component in the AI architecture. And then, oh, look, there's a line that goes to an external IP out of China. Wow, that really shouldn't happen. But you'll be amazed that sometimes when you start analyzing applications, AI or not, at what types of communication flows there are that you may not be expecting. All right, let's open it. How much time do we got left? Oh, perfect timing. 5 minutes. We got 5 minutes for questions. Any Somebody's got a question. Yes.
I know you haven't talked about application authorization. I know that. But if you take the example where you're using your Friday, your ingest pipeline, data source, and you're putting that to your vector database. If you use an example of, say, SharePoint site for HR, you've got granular permissions inside that SharePoint site. You've got disciplinary, HR manager has access, one member of staff who's dealing with it has access, the wider HR team don't. Have you got anything, was it on your roadmap to look at how you maintain those fine-grained access controls so that when the chatbot that everyone in HR has access to, the DFW, they only get access to that one particular configuration they're allowed, they don't see all the HR disciplinaries?
So if you're using the services that we have, private AI services in there, and we were working through our data indexing retrieval service, what we're looking for there is you would create multiple knowledge bases, data sources for each one of those, and then create an endpoint for those individually. Then you can assign a person that may have access to multiple of those data sources, or you have somebody that can only see the stuff that's open to everybody. So right now, we would control that through multiple data sources being directed behind different front ends, and then that would trickle into the firewall rules depending on who has access as well. In the future, we're working on other ways to see if there's other ways to tie individual role-based access control. Right now, though, that gets hard. Once everything gets into the database, the AI wants to be helpful. It just wants to give you the best answer, so it's going to look at anything it has access for. That's why we separated out that beforehand.
Very difficult to make
Yeah.
decisions, but if you've got big enough groups of entities, you can do exactly as you described.
Yeah.
Let's say you've got 3,000 documents in there, all with different provisions. You can't have 3,000 different chatbots.
Yeah.
Correct. So usually when we're talking about that with customers, intelligence community, it's like 4 levels of security that we're dealing with. Or in private entities, it's 2 or 3, like finance has something very specific, legal has something very specific. So we're dealing with a handful that they can manage. I agree, if you're doing 3,000, it would be unrealistic. But all the implementations and all the customers I've been talking to, it's a handful.
Good question. Any others? Yeah.
Is vDefend part of the VCP or is that extra?
It is an add-on to VCF. Yeah. The firewall stuff is an add-on. Yeah.
So the AI capabilities that watch a lot of the infrastructure, could I have it also kind of help with productivity? Like if we're having architecture meetings, trying to focus on the conversation at hand, but it can kind of take notes for that meeting and lock them and put them in the database so in 6 months, when everybody's on other projects, we just chat with that meeting essentially, or that archive.
So there's going to be like a couple different levels to that. So the first level is the system that we have built out is more for inferencing right now. So it's taking data you already have, but you can inject new data into that. So what we do have is like customers that will take meeting notes, take those transcribed notes, dump them into the network share that we're then revisiting on a regular basis, and then pulling those in. So we're working as an internal with Broadcom, 26 different divisions, and we have a bunch of AI projects that are in initial stages. One of them is to take kind of what you're saying of take all our known documentation we create for customer engagements, work with a customer to answer a quick, survey, and then create the first pass of those documents for customer deliverables that we can then edit. But what happens here is we're trying to get the initial bulk of getting the stuff created, and we just edit afterwards versus creating everything from scratch. So right now what we have is you take those notes, put them into a share, we're going to index that share and then pull it in. If you took some extra steps on your own, you could work with either some open source tools or something like that to be a little bit more full featured, pull it in there and use our data source for storing the data, but then have something else that's going to be higher up than what we're currently delivering today.
Or Confluence page. I mean,
Right.
any source, right? I mean, you could take all your notes and just put them into a page and have it read the page every time.
We use that for customer notes. I put all my customer notes into a Confluence page, and I don't know if anybody's worked with Confluence. Searching sucks. So it's easier for us to actually use the chat bot that's indexing it to help us give us information and then point us to the page we want. I actually went on PTO a couple weeks ago. Somebody couldn't find my notes. They searched the demo Confluence page, chatbot that we used, and they were able to find my notes and actually like find everything they needed easily without me being involved in everything, which was really nice.
Yeah, I'm thinking of this thing. We had a network engineer who left. He'd
Yeah.
been there for 10 years, knew everything about the system. Left, did a fair job of documenting, but there's a lot in his head that we don't know.
Yeah.
And so we could stop that problem where it's like all the meetings you've been on, everything you've done and given to the company, it's indexed.
Yep.
Get it on and we can query it.
Yeah.
And That's exactly why you want to secure it too.
Correct. I was actually going there. So one of the open source tools you can use, which I've only started playing with, is N8N, and you can point that at different endpoints, and it'll search and give you really good information, which is really awesome. But then it's like, maybe I don't want you to have access to that information. Like, I legit have customers that'll ask me, what happens if AI like gets a hold of our HVAC system and starts turning things off, and we don't want them to? And it's like, okay, well, one, it's not going to do that unless you give it the capability to do that. But two, if you block it down so it can't communicate with any of your HVAC stuff, then you don't have to worry about that. So it's just understanding the risks so you understand what you're opening yourself up to and what your capabilities you want.
Yeah.
How this would work with the MCP or E2A, like with the rules you can protect?
So we're working for our next version, so 9.1, we're planning on putting MCP support in. For MCP support, we're not going to create the MCPs themselves, but you're going to get them from other vendors or open source. We're going to make them enterprise grade. We're going to put firewall rules around them. We're going to say, oh, this MCP gives you 10 tools you can call, but you want to know what? You don't want your users to call all 10. So we're going to block these 3 from being used and that. So we can partner with that, with the firewall rules and everything. So when we kind of open up that package and ingest it, we can understand what it's doing, what it wants to reach out to, and then say, do we want to authorize this or not? So that'll be part of that like onboarding process for an MCP.
And from a security perspective, we're looking at how to engineer security to be dynamic enough to be able to support agentic AI in a way that allows from the process level to determine should a flow be allowed. So that, as we start to build these tools that say, hey, go do this for me, go do that for me, and it takes multiple steps, that process has to be the one that initiates the execution, right? From agent to whatever it is. Anything else, it would be blocked. That process, yes, we'll allow it. So we have some engineering to do to support kind of this next generation of agentic AI, but we are working on making sure we can do that.
So that process, the underlying assumption is that the other agent is talking to is trustworthy.
Yeah.
If it's not trustworthy, any way to protect the context itself.
So and I think part of the vision that we have is you're only going to allow it to communicate with things that you have dictated you find trustworthy. So by default, it'll say like, I'm not letting it communicate with anything, but you say, I know you can talk to these 3 things. If it tries to communicate with the 4th thing, it's going to be blocked.
Yeah.
We'll see how that plays out as in development and all
If
that.
it's not blocked, it's logged and will tell you what it had. So you'll be able to error on the side of whichever. I want agentic AI to do what it needs to do, right? I don't want a false negative, right? And then it blocks it when it was supposed to. But if it talks to something that I hadn't specifically, it'll allow it, but it'll log it and then I'll get notified about it. So it'll all be how you want to design it and whether you want to be cautious or you want to just play it, by ear and let it see what happens, But all right, we got to hop off for the next one. But if you guys have questions, we'll be